Could just give it a couple of seconds for obviously people to join in. Due to have north of 50 at the minute, we're currently 14. Rising.
I think it should be about 30, 32.
Yeah, just give it, we'll give it till 2 or 3 minutes past everyone.
No problem.
Okay, just another minute and then we can get going, just to allow everyone the opportunity to join into the actual presentation today. Obviously, we've got Bilfinger on today giving us a great presentation. Obviously, Mark and Andy are going to take us through some interesting slides shortly, but we'll obviously just start the meeting off with a quick introduction from the IET and the Manufacturing and Management Group on our side. But we're just going to give everyone another minute and then we'll work through that. Okay, 3 minutes past now, so welcome one and all. Welcome to the event by the IET Merseyside and Western Cheshire Local Network Group. We're obviously the Manufacturing and Management Group, and we've been working proactively through the COVID period to make sure that we've got a steady stream of events for obviously people to take part in and obviously join in and hear some interesting talks around all different topics associated with engineering. Obviously, we all operate on a volunteer basis. And it's always important and a great opportunity for anyone interested in volunteering, obviously, to reach out to myself and Andy and actively take part. And it does obviously attribute to CPD as well. So it's double-edged sword. It's got triple benefits. There's feel-good factor of volunteering and taking an active part in your local community, and it counts towards your CPD on your CNG application. So it all looks good as well. But obviously tonight we've got Mark and Andy from Bilfinger taking us through some automation opportunities and what they've currently been working on as part of the Bilfinger group. Obviously, the aim of the IET and the local network is obviously to share engineering success and innovation. We raise awareness of the importance of design, manufacturing, management, and their integration, and obviously promote novel technologies within the local region, obviously supporting all of the local business, obviously to spread the word about the opportunities, the projects, and the things that are actually working on that add value to the obviously UK economy, as well as obviously engineering as a whole. Obviously, the benefit of obviously being involved is you get to come to events, join in with the group, involve your company, and obviously work to promote an engineering, not just for our local peers, but obviously for younger generations as well. We can't obviously leave out the younger generations. They're important. Obviously, there's a shortage within the industry for engineers. So anything we can do to promote the industry to our younger individuals is obviously a great benefit to all as well. I'm Michael Gilbert, obviously Deputy Chair of the local network manufacturing and management group. And with us today, we've obviously got Andrew Caldos, who's the actual group chair for the manufacturing management group as well. And our local network is headed by a chap called Godfrey Evans. So we're all available to be contacted if needed. But obviously do contact us, get involved, take part, actively participate. It's all for the great benefit of obviously supporting engineering in the community. Obviously today's event is, as described, around Bilfinger automation and digitalization. We've got obviously Mark Kelly and obviously Andy Cooper with us today. Obviously Andy Cooper will be taking over at the start, obviously introduce Bilfinger and what they've obviously been doing. And obviously Mark will finish off with some more interesting slides. So what I'm going to do for now is quickly go through housekeeping, then I'll hand over to the chaps. Should take about 35 to 40 minutes. We'll have a Q&A session at the end. Obviously, please pop your questions into the Q&A box. I'll obviously work through them towards the end, and hopefully we can get all of them answered. And we'll return to this slide as well for anyone looking to get CPD certificates or those sort of things. They can contact myself through the email address in the slide. But for now, I'm going to stop sharing and hand over. Thank you everyone for joining.
Thanks, Mike. Okay, evening everyone and welcome. I guess just a couple of introductions first. So I'm Mark Kelly, I'm Head of Digital and Innovation. Anyone who's attended our sessions for the past few years on these IET events will probably see my face before. But I work for Bilfinger looking at digital technologies, digital transformation, everything we're doing around sort of innovation and the introduction of new processes, procedures to the business around efficiencies, optimization, that kind of thing. My background is primarily automation though. Years ago I was an automation systems engineer before moving into where I am now, putting control systems out in the field, designing control systems, industrial networks, all that kind of stuff. So the sort of automation, digitalization piece fits quite as a natural place for me. Andy, do you want to do a quick introduction?
Yeah, sure. Yeah, my name is Andy Cooper. I'm a business development manager in the automation group within Bilfinger. I'm a recent starter. I've been with the company since the start of the year. And my background is in control, automation and safety systems, both in product, system integration, and also in the actual development and delivery of control safety systems. Obviously, what we will go through today highlights the changing background in automation and system integration type services that we deliver from the traditional PLC SCADA systems, moving more into that IT, IIoT, digital transformation, and also looking at some additional aspects like cybersecurity and functional safety. I'm going to hand back to Mark for the introduction. We'll swap between us for most of the presentation. The idea is, if you've got any questions, please put it in the Q&A or in the chat. And as a result, at the end of the presentation, we'll provide a copy which will be available for you to download. So there's no need to make notes on individual slides as we go through.
Cheers, Andy.
Thank you.
Okay, right, so we'll just give you, for those who don't know, we'll just give you a bit of a brief introduction to Bilfinger and who we are. Then we'll get into automation as a discipline and the kind of areas we look at around automation, and some examples of the sort of technologies we use. We'll then go through a bit how the digital transformation Industry 4 is starting to affect what we do in automation. And then we'll go through some case studies and things at the end, just to give you a few examples of projects that we've done. Okay, first slide, Andy, please. Second slide. Okay, so Bilfinger Group, we're a German company, so we're part of Bilfinger in the UK, are part of Bilfinger SE, who we've got around 32,000 employees around the world at the moment. Just under 4 billion in revenue last year. So from a sort of maintenance services, engineering, quite a sort of decent sized company within the sort of global arrangement. Within the UK now as well, we've been growing. We'll go into that a bit more shortly. We've also got quite a lot of innovation around the group, so we kind of pride ourselves on providing things that are more innovative to the market. So anywhere we're looking at what you could class as traditional solutions into the market, be that automation, be that even scaffolding, maintenance services, we'd look to innovate around those areas and provide new solutions that a lot of our sort of competitors and the rest of the market don't necessarily do. Next one, please. There's key sectors, so we have a strategy across the business that we call the 246 strategy. So that gives us 2 service lines. So we're primarily focused around technologies as a service line and engineering and maintenance. We work across 4 regions, as you can see there. So Northwest Europe, where we are, continental Europe, the Middle East and North America. And group-wise, we have 6 key areas: chem and petro, oil and gas, energy and utilities, pharmaceuticals and biopharma, metallurgy and cement. However, in the UK, because of the markets here, we're slightly different. We work across some sectors that are similar, but we also work quite heavily within food and beverage. We work quite heavily within nuclear, especially in the automation business itself. Next one, please. Just a little bit of history. I won't read through that line by line, but Bilfinger in the UK, as it now stands, is an integration of a number of previous companies that people on the call may or may not have heard of. So we've gone through quite a history of taking what were successful individual businesses and integrating them into what is now the Bilfinger UK. So that's given us quite a diverse portfolio of services across the business. But rather than that being if you like, a small business that's grown to have those services, we've integrated very successful businesses in those areas into one discipline, into one business, which now allows us to provide multidiscipline projects right across the board, from electrical installation, automation, engineering services, through maintenance of assets, turnarounds, shutdowns, refurbishments, right through to ongoing maintenance and support through the life cycle of assets. So we're an end-to-end service within the UK, providing all of the technologies and services that are needed right through that plant life cycle. Next one, please. So as we are in the UK, up until December, these numbers looked a lot different, but we've recently merged our offshore business up in Aberdeen into the Bilfinger UK entity now. So we've now got just over 60 sites onshore in the UK, and we're maintaining and operating on 40 offshore assets as well. So we've got quite a large offshore presence now, which Bilfinger has always had in the UK, but it's now all integrated into the single entity, obviously as part of that, being able to provide the end-to-end services across the whole range. We're around 400 million turnover in the UK, so of that 4 billion, we're quite a big percentage, given that we're a single kind of entity within the group. Around about 4,500 employees, but that does go up and down as we go through periods of shutdowns and turnarounds in the UK. So that can range from sort of 3,800 up to 5,500, depending on how busy we are. And we've got 13 sort of main locations around the company that we office out of as well, which I'm hoping are on the next slide, Andy. Oh no, that's services, it's the one after that. So as I said before, the services that we now provide are quite vast as a single business. You can see there, again, I'm not going to list through all of those, but we do everything from the engineering design, feed study, concept work, process design piece, right through to the service and support across all of the disciplines that you'd expect to see within sort of industrial construction. The only thing we don't really do is civil works. We do civil designs, but we don't have civil sort of capability in the business. That's something that we'll always partner with or use others. And then you can see the digital transformation piece, which includes the automation, the digitalization piece, sits across everything. So we look to innovate and digitalize everywhere we can across all of those offerings. Okay, mate. And there's the location slide. So you can see there's our 13 main locations. You can see we're spread quite wide across the country. Our head office is Birchwood there, just based out of Warrington. That's where I work out of. But you can see we're spread right across the country, and there's a range of disciplines throughout those different office locations in the countries, depending on the services that we're providing in that area. Okay. Right, I shall hand over to Andy now to cover our automation business.
Thank you, Mark. Yeah, so essentially the crux of the presentation today is focusing on the automation service delivery that we can provide. And I just want to position this to start with, because what we are and how we're defined is depends on who you talk to, and depends on the the way that we're described by different companies. We're an automation and safety system solution provider, system integrator, system builder, but hopefully you'll see as we go through, we've got a few more capabilities than a traditional system integrator, but there doesn't seem to be an official title other than system integrator for us, but that's what our partners call us, that's what our customers call us, and that's also what some of the OEMs who we work with call us. So we consider us to be an independent system integrator, but with a few additional things as well. Just to cover the kind of scope and services that we provide, traditionally you'll see that here you've got a supervisory and control levels here. So control, we're talking about PLC or DCS systems. Within that supervisory area, talking about SCADA systems, and that has traditionally been the system integration capability. As part of this pyramid, we've added in the field devices, because if you're not controlling, monitoring or actuating something, then there's no point in the control system being there. So what we do is we also help specify and provide and supply the devices, actuators and sensors on the actual plant that we're controlling, monitoring and taking information from and using as actuation devices. Moving further up that pyramid, you can see we move into things like manufacturing execution systems. And this is something where we provide like a link in between operational technology, which is essentially the hardware and software of a SCADA, PLC, DCS control type system, and taking some of that information and using it to integrate into the manufacturing process. So taking data from raw materials to the finished product, but using that information as it goes through that manufacturing process. Top of the pyramid is ERP, engineering resource planning, which is more the SAP type systems. We get involved in communicating with, but not necessarily supplying those systems. So the bar on the left-hand side there shows the scope and capability of the kind of things that we're able to provide and what we deliver. So look at the technology areas. Traditionally on the left-hand side, you'll see what a system integrator has been involved in for the past 20, 30 years. I mean, it's consultation design services. So it's including working with a client to produce a requirement specification. We help users to define a user requirement spec, and then against that we'll produce a functional design specification for a system, and then either manage that process on behalf of the client and work together with them, or implement that system based upon those designs and those requirements. We also do feed studies, technical consultations, and also provide connectivity and digital maturity type assessments as well. But that's the consultation type services. Added to that, traditional project management, SCADA, PLC, DCS, as I've talked about, RTU and telemetry systems, electrical control panel, MCC, low voltage switch gear instrumentation that sits around those PLCs and control systems, and the traditional service and support. Now, what's happened in more recent times as we've moved through this digital transformation that people are coming up against, working towards, and how people are adopting, it takes us into things like high-level software and some bespoke applications, moving into things like digitalization support services, where we consult and advise regarding generating, capturing, processing data and using it to optimize operations. Energy monitoring and energy management are good examples of this, where data may well be already available, but is it being used to actually obtain optimal operating circumstances, and is it used to make the operation that's being controlled and automated, is it efficient? And some of that now is moving more into that digitalization sphere. We also provide functional safety along the lines of TUV certified SIL assessments, so safety integrity level assessments, risk assessments and mitigation studies, and HAZOP studies as well. And this leads us into things like cybersecurity as well. So we provide cybersecurity services. Traditionally, what we do is cybersecurity and industrial network design and installation are kind of married to each other. A lot of companies traditionally have got separate divisions and separate departments who will provide the IT and the OT. What we find, a lot of companies don't necessarily do that, and we can help clients in either specifying what they need as part of their control and safety systems, how they match up into and communicate with and become part of an IT solution, or in some larger cases where you've got large manufacturing facilities, they treat it as a completely separate system. And what we're installing as part of the control and safety systems will be a dedicated network, and the OT and OT management will be done by the OT team rather than the IT and computer operations. Just briefly looking at some of the automation sectors and clients who we've worked with. I mean, Mark mentioned the 6 different areas, and they're just broad brush areas. We do step outside of those, but you could probably encapsulate 90% of what we've done as a system integrator within the oil and gas, chemicals, pharmaceutical, energy utilities, food and beverage, nuclear, and metallurgy. And I've got some examples of actual case studies towards the back end of the presentation, which we'll go through to give us a bit more information about the clients we've worked with and the kind of applications that we've been involved in. Technology-wise, we are an independent company. We don't have any axe to grind with regard to product. We're product agnostic or product neutral. So you'll see some of the traditional PLC manufacturer names across here, some RTU, DCS, SCADA, and HMI solutions. We have a range of different ways that we work with clients. We can either meet a site standard. If there's a requirement that somebody wants Siemens because they've got 5 Siemens PLCs on their site, they want another Siemens PLC, we can live with that. We can upgrade and add existing solutions based upon site standards where required. But we can also offer a most appropriate solution that's to technical capability, reliability, cost, performance to match the demand or a specification. It sometimes happens that if it's a greenfield site, or if it's a new application, a new client building a new system, they won't have a specific requirement to have a dedicated product. So what our job is there is to turn around and say, well, let's take a look at what your requirement is. Let's look at what you're trying to achieve. Let's put down what some of your KPIs are going to be, and what you want to, where you want to get to, and if you're going to expand it, how it can be expanded, how it can be used, how it can be monitored, how it can be maintained, and how it can be used in future. And we'll develop that requirement and then take a look at what product is out there to match that requirement that we've helped to define. So being an independent company gives us that extra capability. So to say, well, it might not be necessarily a market leading product. There could be something out there that's quite unconventional, but will meet the requirement and give you some advantages. So we see that as our job, to provide that level of information to our clients. In addition to that, we have a panel manufacturing facility just off the M6 in Lancashire with 23,000 square feet of manufacturing space. We focus on high build quality. We have experience of working in highly regulated sectors for our clients as well, using dedicated ePlan 3D software. And we've got dedicated test facilities for clients' FAT and integrated FATs as well. And what we do there, we can build anything from control desks and cabinets for PLC SCADA systems to control panel design, instrumentation, ESD panels. We do low voltage, medium voltage, and high voltage switchboards. And some of the products that are moving through there at the moment are actually the HV switchboard and panels that we're building for a particular manufacturer on behalf of a particular manufacturer with the manufacturer's name on the front. So we kind of subcontracting to us for us to produce their particular product in the UK. So it's a kind of a feather in our cap that we are a reputable provider of panel manufacture for that particular client. So we'll focus a little bit now on the automation and digitalization. I like to use the analogy of a smart meter to define what we mean by digitalization. To me, there's 2 phases. There's digitization, which is having information available, as in everybody wants a smart meter for their home. Digitalization, to me, is taking that information and making use of it. Because when you have a smart meter at home, do you just look at the smart meter and see how much energy you've used or how much it's going to cost you and do nothing about it? Or do you change the way that you live? And do you change the way that you have the central heating on? Do you turn heating off that when you're not in a particular room? Do you check how much it's going to cost to have the water constantly hot? Do you take a look at when the central heating comes on during the night? A lot of people have got that level of information available to them, but don't necessarily use it. And that is just it's a kind of an example as to how some of our clients approach digitalization. The information that they want may well be out there, and they may well be generating that information, but they don't necessarily use it to their best application. So what we've got here on the left-hand side and right-hand side is an example of how operational technology and information technology are coming together. The operations technology consists of core traditional automation disciplines spanning different industries. The IT domain is an area where we're becoming more and more adept and knowledgeable. And you'll see that there's a lot of commonality. So you've got networks, you've got cybersecurity, you've got SQL databases, you've got specific programming languages. A lot of things are becoming a little bit more blurred, and the line between OT and IT is squeezed ever thinner. Some clients, as I said, have dedicated IT and OT teams, and they know the responsibilities between the two. More or less clear, and rely upon our guidance and support to ensure that both aspects are considered. Cybersecurity has been a good example of who takes responsibility for the cybersecurity in the office, who takes responsibility for cybersecurity on the shop floor with the control systems. It can be two completely different departments. It can be one department. It can be one individual person. But what we try to do is to make sure that the people who are operating that are aware of the different levels and different requirements from the OT and the IT aspects. If you look at IT, cybersecurity in IT is essentially geared around computers and new operating systems and latest technology. And the attacks focus on financial gain, so things like malware and ransomware. OT cybersecurity is a little bit different because you're dealing with legacy PLC and old-fashioned computer systems working on old networks with old operating systems. It's more about attacking or taking control of assets, and it's the cybersecurity that we implement is to prevent dangerous situations and hazardous situations occurring by a third party taking control of an operation. So there's different drivers and different requirements across OT and IT. And we see it as our job and our capability to explain that to clients and making sure that both aspects are covered either by the same department or by dedicated people.
Can I chip in there, Andy? Sorry, just a bit to add. I guess just to add there, one of the kind of fundamental challenges around this area, there's two principles around what we do with data across an industrial operation as opposed to an IT infrastructure, and this kind of sets the scene, I guess, for the challenge we have everywhere when we start looking at IT-OT integration. From an IT landscape, as a general rule, data integrity is the absolute key. That's what IT guys will look at. They will shut systems down, they will turn computers off, they will isolate networks in order to maintain data integrity. And that's the whole, traditionally, the focus of the IT area. Obviously, on the operational side, on the industry, it's availability, it's uptime. So keeping the systems going no matter what is the key on that side. And those two principles, when you sit in a room with an IT and an operations sort of IT focused guy, those two principles really conflict with each other because there's significantly different needs required to keep a system up as opposed to keeping its data reliable. And that's no matter which area you're kind of looking at in this matrix in front of you, that's something you've really got to consider. So a lot of the companies that start looking at IT now to support their operations, there's fundamental changes that can happen that nobody's aware of, which actually really impact the operational systems, but you won't find out until something goes wrong. And all of a sudden your network's been structured for data integrity rather than uptime. So you've got to be really aware of that as we move into this more integrated operational model, I guess. That's it, mate. Cool.
Okay, thanks for that. Yeah. I think as well pointing out that the ability to converge IT and OT has led us to working with a lot of the OEMs and new relationships with some of the traditional IT companies like IBM and Atos, for example, who can benefit from our OT background and those scenarios that Marcus has said that it's the availability of the OT system is the most important thing, and making sure it's a bit difficult to take a PLC system offline to do some patching and updating. Whereas people in the office will have an update Wednesday and it's quite easy for them to do it on their PC. So it's a completely different approach. And that's the capability that we have is coming from both sides of that and say helping that integration within a particular organization. So quickly looking at just some of the terminology, we talk about Industry 4.0, and just as a bit of a background, we can look at where we've come from Industry 1.0 as the steam-powered weaving looms, moving Industry 2.0 as mass production assembly lines using electrical energy. Industry 3.0, probably about at the start of the 70s, looking at automation, computers, electronics, and where we are today with Industry 4.0, cyber physical systems, Internet of Things, industrial Internet of Things, and networking as well. So just to give you a bit of a frame as to where we see where we are and how we operate. some of the benefits of utilizing the industrial Internet of Things and Industry 4.0 in automation. If we take these from the bottom going upwards, and we've talked briefly about cybersecurity, but with increased connectivity that IoT and Industry 4.0 provides, cybersecurity is critical in minimizing vulnerabilities and susceptibility to cyber attack. It's something which we do in our day-to-day business now, that we constantly check in cybersecurity assessments to standards and recommended standard procedures, and looking at risk appetites and mitigation elimination on an alert basis as low as reasonably practical. What we can't do is completely eliminate a cyber attack. What we can do is take a look at someone's appetite for risk, where they see the most important points are, and maybe taking a look at some of those early reviews in maybe helping them to pick some of the low-hanging fruit. And some of this comes down not necessarily to rogue states trying to hack in from different parts of the world. It can just be as simple as people not following internal procedures, using things like memory sticks, and not logging on and off as they should when they enter systems. So there's a lot of things to consider when it comes to the cybersecurity assessments, which we do more and more of now. Moving up there, digital enablement is bridging the digital and physical, including connecting and unconnected, to enable data-driven services and asset insights. Internet of Things development gives us a range of options when it comes to connecting and retrieving data from assets, and that capability of using the information or providing the information that may not be available previously. Edge processing involves performing calculations and filtering at the device level, transmitting processed data rather than raw data. Traditionally, in the past, you would have a PLC or a control system or a particular cell of automation, and it would send every individual signal, including 9,000 alarms, to a particular controller, and expect the controller to be able to understand it and rationalize and take appropriate action. What edge processing gives us the capability of doing is doing some of that processing at the edge level, at the device level, and only passing filtered information and processed data back up to the top end. So by the time the information gets to the top end, it's filtered down to 3 or 4 particular points, and it can be acted upon quickly rather than trying to wade you through an avalanche of alarms. And the top point there is optimization, energy management, using data tools and services and expertise to optimize processes and drive energy efficiencies and savings. It's all about what you want to do with that data. And there's a big drive and a big push at the moment for a lot of operational companies to reduce how much energy they're using. And energy management, energy monitoring is something which we're getting more and more involved in right now. And it's not difficult to do the sampling of how much energy is being used, working out why energy is used in a certain way, how much energy is being used by particular cells within a manufacturing operation, and then looking at how that can be optimized and worked upon, and how we can assist clients in taking that into an optimized solution for them. So Mark, I'll move across to you now, back to the digital steps.
Talking on mute.
Right.
Okay, so how do we get there? How do we take kind of what we've done traditionally within the automation environment and look at the digitalization piece and how we get there? We, and people may have seen these before if they've been on previous IET sessions with us, but we have our what we call steps to digitalization. So starting at the wrong end and starting at the top at number 5, if you like, that's where digitalization, the promise of digitalization leads. So the predictive preventative model, the seemingly continually 10 years away dream of the lights out plant and everything being maintained and operated from remote locations and all that kind of stuff. The panacea, if you like, of digitalization sits at step 5. Step 4, we've then got the high level platforms to do that, the data analysis platforms, the cloud platforms, the technologies and things that Industry 4 brings along to us that allow us to do this. And it's really important to understand within steps 4 and 5 what is achievable. So when you're setting out your goals for digital transformation, when you're setting out your goals for operational efficiency, you can understand what is capable and what these platforms can do for you. However, what a lot of people do is start there. They look at the platform, they look at the tools, they look at the software, and they go, that's great, we've got to operate our plant like that. And fall into the trap of letting the software define what the operation is going to do. And that will never, ever work. Digital transformation, digitalization, it is a bespoking of technology in order to suit your operation. And there is no one size fits all for any of this. Yes, there are tools and things in the market that can be tailored, so you're not starting from scratch, but there's always that level of customization. So we say, right, let's look at steps 4 and 5. Let's understand what we can do. Let's understand where we want to go with the value case, the business case, whatever we want to achieve up here. But then let's step back. Let's look at steps 1, 2, and 3 that you can put within that kind of banner of traditional automation technologies, traditional automation projects. Look at your obsolescence. You know, you're not going to get to step 5 if you've got loads of obsolete equipment in the field, and I'll come on to that in a little bit more detail shortly. Look at your reliability of your systems. Look at your reliability management. If your PLCs, your control systems, your networks are failing all the time, you've not got that data reliability. You've not got that consistency of data within your systems and consistency within your control systems. You're not going to get there. But also, there's another part to that. When you're looking at the obsolescence and reliability, you've got going into step 3, the functionality. You know, what already exists on the site. We might not have obsolete equipment. Everything might be reliable, but it might just be a little bit outdated. That doesn't mean it's not useful on the path to digitalization and digital transformation. We can pull information from older systems. We can pull information from existing platforms. Pretty much every site we come to look at, whether it's an automation project or through another area of the business, maintenance or whatever, plants, assets have lots of information that we've been gathering for years in control systems that can be used as data to analyze to reach some of these, you know, the stuff that Andy was talking about on energy usage. We might already have energy monitoring in place. So it's really important that, yeah, steps 4 and 5, they're great. That's where we're going. That's industry 4, that's analytics, that's machine learning, that's all the stuff that sits in those high level technology clouds. But let's not forget the operational elements. Let's use that and make sure we're using our assets in the field to the best of their ability. So I'll just talk you through now a few examples of how we approach some of those steps as we go through. You can go to next 2 slides on, please, Andy. So obsolescence management. There's a statement on here that I quite like, which is just because something's obsolete doesn't mean that it's useless or underperforming. Just because we've got obsolete equipment doesn't mean we have to take it out to head down the digitalization route, to head down this new industry 4 pathway. We can look at things like, okay, we've got, I'll use round numbers, we've got 100 PLCs on the plant. They're all obsolete. But if we replace 50% of them, then all of a sudden we've got 50% spares for the rest of the plant. If the information that's in those PLCs and the information that's in those existing control systems is useful for us, then we can look at stepwise approaches to digital transformation. You can look at different approaches to utilization and getting the best out of your assets that are on site. Alternatively, if you've got equipment in that is due to be obsolescent, you know, you've got maybe a few years left in it, you can keep that equipment in site and start to augment it with wireless sensors, with low cost industry 4 technologies to pull extra data into the system that you're not using. There's a bit of a, and it's getting better, but for the past few years, there's been a bit of a push primarily from sort of the vendor products guys really on industry 4 digitalization. If you're moving this way, you need, it's all new equipment, it's edge, it's cloud, it's everything else, and that's not necessarily the case. If we look at how we manage obsolescence with a view towards digitalization, then we can be more intelligent about how we transform plants, assets, processes. And what you can see on the graphic on the right hand side there, it's anybody who's doing obsolescence management always squirms a little bit when they see this because it's so high level. But you've got the 4 stages of obsolescence management: the planning, the risk assessments, the management of it, and, you know, the activities and actions that are going on in the field. And all we look to do is underpin that with digitalization. So we say, right, when we're doing the replacement strategy, let's not just replace with the next piece of equipment that's that model. Let's look a little bit towards the future. Can we put potentially a lower cost PLC in there, but then augment it with some remote data collectors? You know, there's different ways we can now approach traditional obsolescence management using new technology, and that's where a lot of this digital transformation piece fits in. Next one, please, Andy. So the foundation element, so linked to that, you know, the kind of areas we're looking at to do this with the obsolescence management: PLC upgrades, you know, legacy replacements of equipment, changes to instrumentation. If instrumentation fails, if it's not safety critical or it's not process critical, we can look at wireless technologies. We can look at various other bits of equipment that are out there on the market now to do this. Communications infrastructure is a big one. You know, a lot of certainly older facilities tend to have older infrastructure, older communications networks, older communications protocols that we need to deal with. But again, there's technology now available to do protocol conversion, and there's technology to do protocol interface and network interfaces now that we can use. It doesn't necessarily have to be a big rip out and replace. And then obviously SCADA systems. For anyone who's got a control system in their plants at the moment, a lot of what you can, you know, not a lot, at least a portion of what you're looking at in steps 4 and 5 around analytics and reporting and maybe even KPI monitoring and process monitoring, that data may already be in your SCADA system, and your SCADA system may already have that capability, you're just not using it. So a lot of SCADA systems have had historians, reporting functionality, all that kind of thing. So again, we can look there at what data you've got, what your existing systems can do already. Next one, please. Well, on to, please. Onto the sensor bit. So as I've said, you know, enhancing with Industry 4.0, this is just an example of the kind of sensors we can use. So wireless sensors for vibration, for temperature, great little things, really low cost. Power monitoring, and Andy mentioned energy monitoring. There's a lot of technologies out there we're using on, you know, the one example there is from Schneider. It's called a power tag, and it literally clips into the bottom of your breaker and provides you with all the power going through that single breaker. So you can monitor power usage down to an individual breaker level, which can be really useful. Bridging devices, as I've said, you know, interfacing, wireless interfacing, communications interfacing. It's all these kind of areas you can look at when you're looking at the whole digital transformation and where do we go with automation and digitalization, that maybe just a little bit of different thinking. Next one, please. Just a note on digital twin. A lot of people are talking about digital twin at the moment. And for anyone who's not familiar with the concept, as a really broad summary, it is a digital representation of your plant's facility or asset. So it's a virtual model of some description that will bring in live data from your process. In the sort of ideal world, it will also have maintenance information in the asset information all in one system. So it is a proper digital replication of your physical facility, that cyber physical system that Andy mentioned before. This is really where digital twin sits in. And that can be really useful for simulation, for modeling, for management of facilities, for remote management. There's a lot of advantages of digital twin. However, it's not an easy thing to do, especially on legacy plants. So you've got to look at, right, which elements of digital twin can we potentially use and get value from? And this is just one example that we use, where we'll use scanning technologies, so photogrammetry and laser scanning technologies primarily, to just capture site information in a virtual model. So the top one is where we can use a scanning system to build essentially a Google Street View type environment of a facility. And as you can see there, we can do some crude engineering works around that with regards to measurements and general arrangements of facilities and tour, and have remote access to that facility basically in a model. And the bottom one's an example of where we need that more accurate engineering data, and we'll use a laser scan and get a sort of sub-millimeter accuracy point cloud. But again, these technologies are available standalone, and if it's just visualization of a plant that you need, it's not necessarily the whole digital twin piece that you need to do. We get lots of advantage of this, and so do our clients now, especially through sort of COVID and everything that's been going on with remote working. Having these kind of scans available to do Teams meetings, Zoom meetings, engineering design over Teams is really useful. So you can look at this kind of thing, again, as applications of elements of the technology that are all part of the Industry 4 digital transformation piece. Next one, please, Andy.
I just think it's worth mentioning as well, Mark, if I can, just there, where we talked about your virtual walkthrough and your Google Street Map type environment. We apply this when we're doing site surveys. And it's double-edged, because what it means is we don't have to have a full team of people on site to do a particular survey. We can send someone with the photographic equipment, the recording equipment, and we can put a Teams view on, so we can actually guide them around the plant, tell them what we want to see, what's behind that panel, what's next to you there, does that door open inwards or outwards, and we can actually get that model built up. We use that in the surveys that we do, but what we also find is that once we've built that model, our clients want a copy of that model for their own use as well. So as I say, it comes in useful on both sides.
Yep. What I'll do, if anybody wants to see that in action, I can demo that at the end of the presentation. We've got a model we can actually show a quick show around there if people are interested. And then final steps, so steps 4 and 5 now, the data-driven operations piece. So this is just our own internal example, but it gives you an idea of what's involved in these platforms. So we have an internal platform called Bilfinger Connected Asset Performance. And this is a cloud-based platform that allows us to bring data in from multiple sources and do everything we want to do around analytics. So we'll do energy monitoring in this, we'll do process reporting, we'll do predictive analytics, we'll do failure prediction based on data. We've done some good examples recently of looking at bearing and motor failures in ways that we've never particularly thought about it before, where we'll take a failure of a piece of equipment, but around the time of that failure and for the months going up to it, we'll take in all of the surrounding process parameters, and we'll see if we can see leading indicators of certain items of equipment. And if there's indications within the rest of the process that they're about to fail, you can see these patterns within the data. And this has meant us changing sort of our approach as well. We have data scientists in the teams now. We have our own sort of data science business based out in Germany that we run this stuff by, and these guys do a lot of the analytics. But again, you need that operational background. The data guys are great. We can send them 6 years worth of information and they will send us a report back that highlights all of the interfaces and all of the interactions of the different elements within that data, but it won't mean anything to them because they're looking at it from a pure data science perspective. You need that operational knowledge to be able to then sit down and go, yeah, well, that point is actually a thermocouple that we've got up here. That point's actually a motor that we've got in the warehouse. And you need to be able to then contextualize that data with your operation to get value out of it. So as you can see there, there's a lot of technologies involved in this area. There's a lot of steps to go through, but the idea is you bring in together data from multiple platforms to actually analyze it and then get insights out of it in a way that you may never have done before. Okay, mate?
Yep.
Go on.
Yeah, so we'll just finish off the story here with a couple of the safety considerations, addressing things that we as a system integrator can undertake and how we work in conjunction with our clients. The first being functional safety. Functional safety associated with safety-related control and protection systems, so emergency shutdown, fire and gas detection and protection systems, but the definition of where these systems come from, how they should operate, how they operate when certain failure modes apply, how they operate in dangerous situations. So we provide functional safety management and functional safety plans, looking at specialist assistance in hazard and risk assessment in different stages of a project life cycle. It allows us to independently assess a current operating facility or a cell within an operating facility and help define a new requirement addressing the IEC 61508, 61511 standards for safety instrumented systems. Essentially, the kind of service that we offer is identification of safety critical elements and development of performance standards. We do COMA reports and safety cases, SIL determination using LOPA and ALARP, for example, SIL verification, full failure mode effect analysis, process hazard assessments using HAZOP and hazard techniques, consequential modeling, QRA, fire and gas detection, protection systems, and 3D mapping systems. So a full life cycle concept of functional safety from definition right the way through to system implementation. And again, that's where we differ slightly from a lot of companies. Some tend to take that consultancy view and provide advice and guidance and give you a report saying what you should implement. And some will pick up that report and then implement a system based upon those requirements and those specifications. Where Bilfinger is slightly different is that we can do the full life cycle. So we will be involved in those early definitions. We'll define what the SIL requirements are, the safety systems requirements are, how the system should operate under certain conditions, and then we can go and implement those systems. Again, based upon agnostic hardware, we will take the view of implementing a system based upon what we see as the best fit from the products that are out there in the open marketplace. So that's the functional safety aspect. Similarly, industrial cybersecurity, we can address brownfield install systems to verify their functionality and resistance to cyber attacks, to network intrusion from external sources, as I say, bad practice or poor implementation of operational procedures. We also address new installations, providing guidance and direction regarding cybersecurity, network intrusion detection, recovery plans, patching, and potentially implementing solutions as well. It comes across in the way that phase 1 is the assessment phase, moving across into phase 2 where we do the analysis, phase 3 is the implementation, and phase 4 is the maintenance and support. So it's ongoing, because after that maintenance support, we continue the assessment. So we continue to make sure that it's an evolving system and an evolving requirement to make sure that we are keeping up to date with latest technology and latest capability. We have experience of working with operators of essential services and critical national infrastructure, which are governed by UK network and information systems, the NIS regulations, which are enforced by UK government. We can also deliver solutions which place out-of-date and unsupportable SCADA systems. As Mark mentioned, a lot of the systems that are out there have been out there for 10, 15, maybe 20 years. They're operating on vulnerable operating systems which may not be updated and supported by the system manufacturers. They're not been able to be patched. They're unable to be updated and secured and ruggedized against cyber attacks, and running on inappropriate hardware platforms. 20 years ago, there was no such thing as an industrial computer. It was a desktop computer that was put in a box. And currently, you're looking at systems that have been out there for 20 years, still operating in those environments. So there's a lot of analysis to be done, which we can provide to take a look at, essentially looking at benchmarking where people are, and also where they think they are. And that can be two completely different positions. So we provide an independent assessment and kind of ask the questions of where do you want to get to, judging on how much time you've got, how much money you've got, how much appetite you've got, and what your risk profile looks like. And it is a journey. We can provide assistance to look at the low-hanging fruit. We can measure deliverables. We can take a look at how that journey is going to go on for, and how long it's going to go on. And I say we can actually have those measurable solutions. So we can say, by doing this, you will improve by that, and you can then improve, and you can take it a step further, and you can continue to move forward. So we'll address that and allocate costs and timing against where people want to get to. So that's more about the industrial cybersecurity. What I just want to do before we finish is just run through very briefly some automation case studies. The first few are systems where we've got an existing operating system, and the client wanted to either change its functionality or add to its functionality or swap out its functionality. So we've got examples of gas field developments. We've provided high availability control and safety systems up to SIL integrity level 3. We've also integrated solutions to CCTV systems. This is a gas field application. Similarly, an existing fire and gas solution, which had a safety integrity level defined, we then expanded and changed the functionality a little bit on that system, but provided extra functionality over and above what it was doing, but made sure that the enhancements were in line with that safety level requirement. So we designed, developed, implemented, installed, and commissioned the control system in compliance with the customer's rigorous standards, again, with it being an oil and gas application, should I say. Similarly, an upgrade in the UAE, this was an aluminium smelter, where the completely new smelter adjacent to existing smelter to double the production capacity. So what they wanted was a similar system to what they already had, but in a way that they wanted to make sure that they'd got enhanced functionality. So we did the engineering consultancy to start with, told them what they could do, how they could do it, and where they could get to. And then we supplied technical support and guidance to the customer and to the OEM vendors, to ensure that all the automation networking elements met the customer standards as required. Look at some new installations now rather than upgrades and replacements. This is control system provided control of cell culture processes. Again, we carried out detailed design, programming, installation and commissioning, and validated the automation system to the good automation manufacturing practice, the GAMP standard within the pharmaceutical sector. Similarly, work done in the nuclear waste safe storage control and monitoring. Because of a number of ponds which were used to safely store nuclear waste for short periods of time, but the storage ponds weren't suitable for long-term storage. So we awarded a contract to provide a solution to address the risks of moving from one pond to another and extending that capability of storage. And it was designed around a control and safety system, PLC and plant simulation software. And some of the KPIs are monitoring and reporting integrated into the existing SCADA system, which we also upgraded as well as part of the operation. We talked a bit about energy monitoring. We've done energy monitoring systems, essentially providing web access to BMS, LMS, HVAC, CCTV, electrical systems to be able to provide, as Mark mentioned, the availability of information which probably already exists, but isn't necessarily used or applied in the right way. And implementing a system, a low-cost system here, saved £200,000 in the first year of operation, because they were able to monitor individual energy usage within around particular cells and particular areas of the operation. Production improvements. This is a dairy product manufacturer. We provided effective reporting using Historian and an NAS to deliver greater transparency for the facility's data. Essentially, they had the information available, but they weren't using it in the way that they needed to. So we provided them with some background tools to enable them to make their operations run more efficiently. And going back to some of the refurbishments, hydroelectric control scheme in North Wales. It actually sits in a Grade 2 listed building, which is a control system house. It had several upgrades, and we were awarded a contract to complete replacement of the system using automation solutions. To replace the unit control PLC, electrical panels, and contactors. An additional SCADA system as well. This project is a project where you've got a pipeline delivering petroleum products across the UK, essentially used for airport systems, but delivering product in a number of different pipeline systems. And we delivered a complete solution, including replacement of existing control panels and site installation of legacy ESD and SIL-rated systems to replace them with a safety PLC solution. Developed innovative changeover strategy to help keep the pipelines operational through the install and commissioning phases to make sure there was no downtime. So those are situations where we could plug one system in and it operated alongside the existing system. And when the systems were aligned, we could then switch the old system off, and we did that on 12 different locations. And the final one here is a waste effluent treatment project in the nuclear sector. We work for about 3 or 4 different sites in the nuclear sector in the UK. I can't tell you where they are, but if you know there's 3 or 4 of them, you probably know where they are. We're awarded a contract here to deliver a control system upgrade and a cybersecurity solution as well. Also looking at the cybersecurity lifeline process in line with the IEC 62443 standard, ensuring appropriate assessment of cyber risks, implementation of chosen technology according to risk. So we took an independent view as to what their risk profile was and provided solutions based upon that, based upon their time constraints, their budget constraints, and their processing requirements. And that completes the presentation. I don't know if we've got any questions. I'll leave that up on the screen. Are we doing questions now? Mike, do you know if there's questions been flying into the chat box?
There is questions, and they have been flying in, but we don't have vast amounts of them. We're fortunate enough to have 5, and 5 very good questions they are. I'll start at the top. I'll start with Mark. Mark has asked, have you done anything in laboratory automation, QA or R&D?
That's a relatively easy one to answer. No, we've not. We have looked at a few projects around laboratory automation, but they've always ended up feeling a little bit too product heavy for us to get involved with. So we've not really done anything within laboratory automation at all.
Okay, that's Mark's answer, and I hope that was satisfactory for you, Mark. If you've got any questions or further questions surrounding that, just pop them into the question box. The next one comes from Tim. Tim has asked, well, Tim's got 3 questions, so I'll rattle all the Tims at once.
Okay.
So obviously the first question is, how do you get the accountants to cough up the cash to upgrade to 4.0?
Do you want me to answer? Yeah, I'll answer these one at a time. Right, interesting one, this. It depends. So generally what we'll try and do is build a value case, but the way you build that value case varies depending on the application. It comes down to this tailoring and customization. And trying to, when we first started looking at digitalization, we're all engineers, we all got very, very wowed by the technology and the products that are out there, and suddenly went out to our clients and tried to work out how we suddenly sell all this new shiny stuff so that we can put some fun stuff in there. But what we very quickly began to realize was it's not about the technology, it's about the business case and the process improvement piece. And if you look at the process and the understanding of the process and where the value is coming from through, a standard business case sort of processes, you soon justify the value of the upgrade to Industry 4, especially where you start looking at some of the wireless sensors. And we've used some of the cheaper technologies to justify the cases for larger investments. A couple of examples: wireless temperature and vibration sensors, where we've just gone around a plant and put multiple of these around and justified, look, your equipment is actually really bad from a vibration and temperature profile. It's going to need replacing, and you're going to see this, and you see this value. We've done it based on purely analytics of data. So with one client, we took 6 years worth of their operations data, and we looked at downtime of assets and calculated that back across the cost of downtime to the process, and the values that came out of that from them just not understanding when things were going down and justifying the investment in the analytics. There was one asset for this particular client that had cost them over 1.5 million in downtime in 3 years. So you can start to use the technology to justify the implementation of the technology, but it is all about the use case.
I think as well, Mark, there's also a case for starting small and building big. We don't expect people to start investing multi-million pounds when they don't have the faith. A lot of what we do is on a small isolated case, look at a particular cell within a particular area and do a proof of concept. Just let it tick away for 2 or 3 months, come back and show the client what information he's now got available, what he can do with that information, and then convince him that making that investment will have a direct impact on the bottom line. Yeah. So it's that value case, and through the proof of concept is the easiest way of doing it.
And I think that's where we've seen, we as a system integrator, though, that's where we probably see the world a little bit differently, because we know we've gone into clients where maybe some of the bigger vendors have been in before us and tried to sell them this dream of the Industry 4 world, and it's all tens of thousands of pounds of hardware and everything else that you need to put in. We come in with the no, let's follow the steps. Let's look at what you've got in there. Let's look at how we invest sensibly moving forward. It's a different view when you're not looking at it from a product and a technology sell.
No, I agree with you there, and definitely in terms of the wireless sensor like integration options, you can get a ABB Smart Ability G2 high performance for, I think they're £355 for a one-off with a £70 subscription for the year, and you're away. So it's what, £420 and you're off.
Yeah, it's that kind of stuff. It's all out there. Yeah. It's a matter of understanding it.
Definitely. I hope that's obviously answered your question, Tim, and I'm just going to start working through your next ones as well. As obviously, your next question is, where do you draw the line on saving of info, as many companies have big amounts of useless data, i.e. nice to haves?
Interesting one, this. Becomes a bit more interesting with the cloud side of it. Depends where the data is going to be stored.
It's cloud rate as well.
Sorry, mate.
It's poll rated, I'd say, as well, just to cut across you. Sorry.
Poll rate's one part of it, but you've got less limitations on data volume as you start using cloud-based systems. To store information in the cloud is relatively cheap. So it's use case based. If we're looking at, we've got some systems where we're polling every second, we're storing all that data in the cloud and we're doing analytics on it. and all of that data is being kept. We've got other systems where it's on a localized system. We've got limited storage, maybe in an edge system or at a local SCADA, and there'll be a 3 or 5 year purge. But it's all based on the volumes of data rather than timescales around it. But like I say, moving towards the cloud changes things. Cloud's a dangerous topic to get near, because everyone talks about data lakes and putting all your data in the cloud and everything else, and it's, you know, 200 quid for the year and we'll store every bit of data your plant can produce for 10 years. That's absolutely brilliant until you want to process any of that data in the cloud. And then you start looking at real costs, because what you cost in the cloud come against is processor cycles. So there's a real advantage to storing data in the cloud, and it removes that kind of concern about limitations of data storage and timescales. But you've got to be really careful what you do with it. So again, I know it's a bit of a get out, but it's a use case based scenario where you've got to get multiple factors into case.
Thanks for that, Mark. And obviously the last one from Tim is how do you overcome the fear of moving from the desktop in the box to more modern hardware/software systems where senior management are reluctant?
More and more, it's now down to obsolescence and cybersecurity. You know, you start moving towards just the sheer hack now, where you've got a control system sat on desktop. You know, your desktop technology starts becoming out of date in 3-4 years now, and if you follow that old architecture where you've got multiple desktops around there, you're going to have that impact of cost, not only on the hardware side, but also on the transfer of the control system. Where if you start to move to newer hardware and you've got virtualization in place, where maybe you're working off virtual machines, the transfer from different hardware on a 3-4 year basis, you're paying for one server, transferring all your virtual machines over, and then your one system goes out and you're away again, or your two if you've got redundancy in place, obviously. But more and more, it's becoming a cost, obsolescence, and cybersecurity justification rather than a cost one.
Okay, thanks for that again, Mark. And we've got one last one from Chris. Have you applied any of this thinking internally, and how are you digitizing your own engineering/design delivery?
Yes, we have, which is why we've ended up where we are these days. We've spent the last 4 years kind of looking at the different areas of the business, and I think, as I said at the beginning, kind of digital and innovation, my department covers more across the business than just the engineering automation piece. So, you know, we'll work with the scaffolding guys out in the field, looking at digital forms, looking at simple things like, you know, GPS data for scaffolding, looking at industry 4 sensors, looking at how we use digital twin and scanning technologies. The biggest impact for us by far were 2 areas, I think, where we've used virtual reality and 3D models for the engineering design piece has been a really big one for us. So taking the industrial 360 thing that I showed earlier and scanning the sites quickly and easily, and having that really detailed site information available for the engineers to be able to access, hugely powerful. Just a simple, you know, a really easy example. Traditionally, you'd go to sites, you'd take pictures of all the areas you're interested in as an engineer, you'd make your notes, you'd head back to the office, and then all of a sudden, somebody wants to move the panel to the wall behind where you took the photo. And now we've got the 360 scans, we're turning around in the model and looking at the facilities of doing that. So you're bringing in a lot of efficiencies there. And then taking that into the virtual reality world, we're then doing in-model design studies, accessibility studies, maintainability studies, and just being able to stand within the virtual models and reach out your arm when you stood on a platform to see if you can reach a valve or an instrument or a sensor. Really, really powerful. But don't get me wrong, we've done a lot of stuff wrong as well. You know, we've played about with multiple technologies over the last few years and kind of worked out what works and what doesn't. But we're applying these principles. The principles I've presented today are the exact same principles that we use internally when we're looking at any digital project, regardless of the discipline.
Great, and I think that's everything answered, Mark. Obviously, thank you to yourself, Mark and Andy, for giving this wonderful presentation. If you could just stop sharing your screen, Andy, I'll pop the email addresses up for myself and Andy, and obviously we can be contactable for any CPD certificates if needed. But yeah, obviously thank you everyone for coming. It's obviously been a great opportunity to hear about digitalisation and automation from obviously Mark and Andy and the team at Bilfinger. But I'll leave this up for a couple of seconds, as obviously I've spoken about before. If you want a CPD certificate, email myself or Andrew, and then hopefully we can hear from you in the near future, and look out on the IET website for all of our up and coming events in the next couple of months to get advertised regularly. And obviously we have got some new interesting events coming up in the near future. So I'm going to stop the sharing now, and then that should have given you enough time to jot down any email addresses. But again, obviously, thank you everyone for coming.